Very nice work. Thank you, Kaital.
Yes.
Questions from audience? Right. We have one question from Hassan. So let me try to read it down. The question is regarding the perceived RSSI at the sensors. So RSSI depends on the distance from the transmitter as well as the transmission power. So does your algorithm accounts for the different transmission power from the different transmitters?
Yes, this is a very good question. So the transmitter power do affect, and during the evaluation, I varied the transmitter power in a range that the range is 5 dBm. And honestly speaking, if the range is too large, then it will start to affect the algorithms. It will affect the algorithm performance. So I did vary the transmission power, but in a limited range.
Thanks. I think that answers the follow-up questions also. And the question was, is it possible to throw the localization algorithm off by varying the transmission power?
Yes.
So
yes. In the paper, I stated that the range of the power is 5 decibels, 5 dBm.
All right. Great. Thanks. Other questions? Yes, I have one related questions. So you have used receive signal strength as the input to your model, but in wireless, you have multipath. So when you have multipath, means signals can be reflected from different objects and can be also blocked. The line of sight can be blocked. So the distance relationship from the transmitter could not be maintained just by using RSSI. So do you have any thoughts about how your algorithm would behave under practical multipath channel?
Yes. So multipath is the nasty stuff. So, but because we're using deep learning and we're collecting many data samples, so we hope that deep learning can somehow capture the multipath stuff. The simulator we are using is called Splat. It is a kind of realistic simulator that includes the geographic territories. It will include the mountains and the stuff in it. So I think the data that the simulator called Splat provided to me is including some kind of the multipath informations. And with sufficient enough data, we hope that the deep learning can incorporate that.
I see. Thanks.
Okay, and I want to answer the previous question again. So the one with the transmission power. So actually we were so our DeepMTL is comparing with 3 algorithms, and one of which is one of our previous work called MapStar. So one of the capabilities of MapStar is that it has a capability to predict the transmission power. And if you're interested, you can take a look at that MapStar paper.
All right. Thanks. Any other questions? I guess I have one more question. So your transmitter are considered to be static. Now, does it also work under mobile transmitters?
Okay, so for every instance, we consider the transmitters are static, but the localization is happening in a time series. So, like at this second, we collect the data and we do the localization, which is one instance, and a few seconds later, we then do the process again, right? So if the transmitter moves to a new place, then that would be a new instance of localization. So a series of localization can be viewed of tracking, which of course tracking should include more stuff there, but a series of localization can handle the basic issues here, I think.
Thanks. And I think I have one more question. Is you mentioned about distinguishing or capturing unauthorized transmission,
yes.
right? Could you comment on like how would you distinguish between unauthorized transmission and authorized transmission after you have localized all the transmissions?
Yes, this is a good question that I did not mention in the talk. So what we're doing is that we localize all the transmitters that includes both authorized and unauthorized. So we're distinguishing them because the authorized transmitters because they are authorized and legal, so we will have their information. So they're kind of known. So we can then just we remove them from the localized transmitter list. Then if we remove them, then what is left will be the unauthorized. And I want to mention that in our other paper, the map star that we compared, we have another scheme of dealing with this issue. If you're interested, you can also take our previous the map star paper.
All right. Thanks for the answer. Okay, so if there are no other questions, let us thank Kaitao. Thank you, Kaitao, for your nice work and the presentation.
Thank you.
All right, so our final paper in this session is